Tonight on Newswire LA, we continue our look at the Museum of Traffic Control. All of that and more coming up right after the credits. Tonight we continue our look at the Museum of Traffic Control, which was originally based in Fullerton, California. You can see we were having a great time being with John and his collection of signals, signs, and other memorabilia from motoring history. And we've learned a lot over the last week. Well, we're going to continue that, and we're going to continue to mix that with more motoring and Los Angeles history. Sit back and enjoy, and we'll see you back here shortly.
This is the neon walk don't walk that uses a plastic legend in the front.
Mm-hmm. Now, did those plastic legends, like most other things, become brittle over time?
Yeah.
And crack away?
Yeah, eventually with sun exposure and such, they can become brittle. As it is, this one hasn't been opened in a while.
Little WD-40, you say?
Yeah. There we go. Getting there.
There we go.
Come on. There we go.
Now this, unlike the other exposed tube neons, they have the appearance of the words that they're supposed to be, but except for the walk portion. But this looks like it's an insert. Looks like it's an insert into what could have been another type of signal. Could you give us an idea about that?
Yeah, I mean I think this one was made for this style actually, but a lot of times they were modified with the case being made for one type of signal head, and then as things became different and more efficient, they would basically gut it out and put new modules in their place. This one I think was for this style signal. It won't let me do it with it on, but if you want I can turn it off and we can look back there.
Yeah, it's like we can do that in a little bit.
Sure.
All right, I'll take it down. All right.
Okay, and then when I pull off this, you can see how the two transformers here, basically these mate with these little holes here, and that controls the walk and the don't walk by the transformer. I think this is the don't walk and this is the walk transformer. And it goes through a fusible link there. And it's just that easy. These are pretty heavy because of these neon transformers. But
now this whole device is indicator control, so it was indeed made for that.
yeah.
But they did make these types of packs to refit the Econolights
Yes.
and some of the others that were in.
Yeah, and I'll show you. I have one coming on down the line here that was retrofitted into.
Neon began disappearing from the traffic landscape in the 1980s when cheaper and easier to maintain incandescent units were chosen as replacements. However, if you look hard enough, you can still find a few neon Econolights in service around LA. Raymond Chandler, wherever you are, we know you're proud. If you asked the average Californian about the storied history of our freeways, we'd be hard-pressed to give an answer as to its origin. The freeway came into existence for several reasons. Our streets were not designed for the increasing traffic flow it was supporting. Public transportation was decent, but drivers yearned for more destinations. Finally, there was the speed factor. Engineers called their new high-speed roadways parkways because a drive on one of these roads would be as scenic as a cruise down the Miracle Mile, just faster and with no traffic signals or cross traffic. This parkway ran from Hollywood to Pasadena. Crews tunneled through 3 small hills in Elysian Park that separated Chinatown and South Pasadena. The Arroyo Seco Parkway opened in 1940 and is best known today as the Pasadena Freeway, the nation's oldest. This stretch of heavily traveled pavement came into being in the post-war 50s. Despite being christened the Ramona Parkway, its building was anything but joyful. By the time it was completed in 1955, $56 million had been spent, and neighborhoods from East LA to West Adams to Venice had been raised. Today, the Ramona Parkway is known as the Santa Monica Freeway, Interstate 10. Speeds at rush hour can be as low as 5 miles per hour. The 10 is part of the interstate freeway system and touches both coasts, making it the longest freeway. Finally, there was the Slauson Freeway. When construction began in the 1960s, the freeway met with harsh opposition from communities whose memories were fresh of the construction of Interstate 10. As a result, the freeway begins at Slauson Avenue and ends at Culver Boulevard in Marina del Rey. It passes near Loyola Marymount University and crosses Bologna Creek for a grand distance of 3 miles. The renamed Marina Freeway is the nation's shortest freeway. Along with many other icons of American culture, the traffic signal has its own corner of Americana, according to the Signalfan.
For me, it is part of nostalgia, such as like the car hop and the drive-in movie and things like that. To me, it takes to an era, even though it was before I was born, but the 50s glow, or the 50s era of the stoplights hanging down in the middle of First and Main, and that people driving through town would have to stop at the one place in town, basically, and that things would happen in that one area of town because that's where people would stop and gather and stuff like that. So there is kind of a nostalgic aura about the main light downtown that all the little towns had across the country. There was always one traffic light in a lot of these towns, and so that brings up a good nostalgic feeling.
But small-town Americana was being lost as larger cities like Los Angeles brought the freeway system into existence. The job of regulating traffic flow was left to the old dependable street sign, which actually predated the use of signals.
I mean, originally the early signs were just a piece of steel with paint slapped on it and wording stenciled onto it, letters. As it progressed, the corners of the signs, the sharp edges became more rounded, began to get borders around the edges so that the sign would stand out more, and they went to porcelain enamel over steel, and then from there, as traffic became more prevalent at night, they went to reflectorization of the letters with cat eyes, which were glass beads that would be drilled into the sign and create the letters, so at night when the headlights would reflect those out. The glass beads were used until after World War II, and then they went to plastic. As plastic became more prevalent, they went to plastic reflectors, and those pretty much were in use until they stopped signing, I believe, around the mid-60s, around 65 or so. The Auto Club stopped making the signs. Actually, the Department of Highways, which took over the signing, stopped making the reflector signs. They went to Scotchlite and sheeting and all that stuff.
Signalfan shows us some examples of early signage.
Most of these signs are 1950, actually 40s and 50s. The Auto Club signs were mostly early 50s, maybe late 40s, because they used the plastic reflectors versus the glass. After the Auto Club, the Department of Highways, California Department of Highways, took over signing. And like this Long Beach city limit sign, there's the logo at the bottom. They used a winged tire with a spade and shovel on their logo, and they took over signing in the 50s from the Auto Club. This sign here was used in front of Mission San Juan Capistrano. Ortega Highway is Highway 74, and it ends right in front of the mission, so that one has some local significance.
Now, how did you come about getting all of these signs?
Again, this one I got from an antique store, and I don't think they knew at the time what they had. But most of them I've gotten from there's a friend of mine that's up in Sacramento that trades a lot of signs, and to get my collection started, he let me buy some of them before I got to a place where I could start trading some signs with him.
Signs were erected in California and the West by the Automobile Club of Southern California, or AAA. Later on, the California Department of Highways and local cities took over. The department was later renamed the California Department of Transportation, or Caltrans. Modern technology regulates traffic flow onto our freeways through the use of meters that allow 1 or 2 cars per grain to enter the freeway. These devices are controlled in the same manner as any normal traffic signal.
This is the Caltrans version of traffic control.
The ramp meter version.
Yeah, well, this is actually for a full 8-phase intersection, but also same thing, can be used for ramp meters and such. All the vehicle detectors are here. Load switches are there for the lights. Conflict monitor unit down there. And this is basically 8 phases. So you have your even phases or your through phases. Your odd numbers are your left turn phases. So you can control basically the whole works from here. It also had a feature that has advanced warning beacon control. So if the light was going to turn red in like a place where you really can't see it, it'll engage some advanced warning beacons, signal ahead signs, so you can know that the light's changing before you get there. It has all that technology all wrapped into one. So it's a pretty nifty little machine.
And again, you got all of this stuff, including the modern stuff, mostly through contractors.
Mostly through contractors. And then this actually shows an intersection diagram of what you're seeing. So the person working on the light could come back here and see what was green and what was red and what it's doing. You got your left arrows, your straight through, and then your right turn overlaps. And your walk, don't walks.
And you can see even in flash mode as well.
Kind of a good intersection at a glance.
With larger amounts of traffic on our roads, it became necessary for a unified code of signal operations.
I think standards had changed. There began to be national standards to control devices. A manual came out called the Manual of Uniform Traffic Control Devices in the 20s and 30s to gather all these communities together, because everybody kind of started their own signaling idea and try to unify the country together so people weren't confused from being from one city to another. They began to create standards on signs and signals that everybody could adopt the same color and shape and style, so drivers weren't confused. This was each manufacturer's own idea of what to use for a traffic controller. So they all had different connectors. They were all military style connectors, but they were different in the pin configuration and how many pins were used. So you couldn't interchange the units from manufacturer to manufacturer. Basically had to change out the whole cabinet.
Now, what do you mean by a military style connector? What is that?
They're basically connectors that were used in the military. This is usually a rotating locking ring. This one will go into flash now as soon as I pull it out. Yeah, there it goes. And they were used during World War II and such for their equipment, sonar equipment and whatever else have you. So a lot of the traffic controllers utilized these multi-pin connectors after the war.
Engineers sought to set a standard for the equipment controlling signals, and in 1976 introduced the NEMA Standard.
It's NEMA. It's a NEMA standard with a typical NEMA plug that all controllers have. It has an older conflict monitor. The conflict monitor basically it senses the current output of the different indications, and it ensures that no 2 greens come on at the same time or any conflicting indications. If it senses that, it will kick the controller into flash mode, so there won't be any accidents or any problems. So it's kind of electronics, controlling electronics, kind of monitoring the intersection keeping everything good. Again, it's the low voltage, spits out of the controller, goes into the load switch, which controls the high voltage, which runs to the signal head. And that's where these wires go out to the signal heads.
So they go down through the ground back over to the individual signals themselves.
Yes. Yeah, I have these labeled. I've got phase 1 and phase 2. Phase 1, phase 2 vehicle. So you got your red, yellow, green, and red, black, blue, for lack of another red, yellow, green wire. And then your vehicle or your pedestrian signals, your walk, don't walk. And then the push button and the vehicle loop sensor is the last two terminals in.
Now some of these signals have what they call a police door.
Yes, and this one does have that. If I close this cabinet back up. Basically here is the police door. And inside here, other than my remote here, you had two switches. You have your auto flash switch, so the officer can put the intersection into flash mode. And you have your on-off switch, so the officer can turn the lamps off. The reason they had this separate door is that the officer then can't mess with any of the other coordination functions or the other things that keep the controller running. This would basically turn the lamps off, but all the electronics are still running as if the intersection is running for traffic. So it kind of gave the officer control over the intersection, but not to fiddle around and make a bigger problem out of the coordination.
Okay.
NEMA stands for the National Electrical Manufacturers Association. The aim was to standardize aspects of equipment interchangeability between manufacturers, environmental requirements, and input-output connections. While NEMA was being adopted as a standard, Los Angeles and New York developed a microcomputer-based system called the T170.
And this one, the difference between this and a NEMA is this is all software related, where a NEMA is more hardware. Basically, this part pulls out, and you can put different software in. A lot of times, City of LA can use these same boxes to use for sprinkler control, for freeway ramp metering, for traffic signals. I mean, just by putting a different module in there. It's basically a microprocessor computer with different software. So that was a different thought process, rack mounting and all that, than the NEMA, which used the shelves and the hardwired machines.
So it's upgradable, basically.
Yes, which is why you still see these cabinets and stuff. They're easily upgradable.
A generic processor in the T170 allowed it to be programmed for use with sprinklers, ramp meters, and other functions not necessarily related to signal control.
It looks from the outside like an electromechanical signal, but as soon as you open it, it's kind of like retrofit. Basically, as the controllers were getting older, it kind of like came out with this version, in that you could do in the field, you could take out all the electromechanical guts, if you will, and slide this right in, and it will control the same amount of signals. You'd have your vehicular signals and your walk, don't walk. So again, I have dummy loads in there so it won't go into conflict flash.
Although some solid-state controllers do not conform to NEMA standards, they are NEMA compatible. The T170s are not.
This is a modern NEMA cabinet. Shows you kind of how the signals are set up today. You have your controller unit. This is a Multisonics, which has the